Hi and welcome to the videos for section 1.6 for Math 181. This is the first of 4 videos. They're a little bit shorter, but I wanted to keep them a little more concise, so if you have to go back and look and refresh on these videos, it's a little bit easier for you. The reason I do that is because this section up until this point, we've been talking about limits that are going to some number. As we plug it in, if it's within the domain, it kicks out some number for us. In section 1.6, we are talking about limits involving infinity. So here, either the limit goes to infinity and beyond, right? Like the movie. Or what if the limit approaches infinity? What happens to the function at that point? So recall from earlier in this chapter, we had that the limit as x approaches 0 of 1 over x squared, we said what? We said that this limit did not exist because the picture looked like what? We saw this in the discontinuity as well. So we said, well, it didn't exist because it was heading towards infinity. It never approached a specific value. So a couple definitions. So definition 1, we have that the notation, the limit as x approaches a of f of x is equal to infinity means the values of f of x can be made arbitrarily large arbitrarily large by taking x sufficiently close to a but not equal to a. So we're back to this idea of limits and getting close to a number but not actually at that specific number. So for example here, as I get close to 0, whether it's from the left or the right, doesn't really matter, the limit goes to where? It's going to positive infinity. It becomes arbitrarily large. And the same thing, so this is also valid for the limit as x approaches some value a of f of x is equal to negative infinity. So it just means that the numbers can be made large on the negative side as I get close to some value a, but not actually equal to that value a. So now instead of saying, well, the limit doesn't exist, now we can actually say the limit is equal to positive infinity or the limit is equal to negative infinity. Another definition. So the line x is equal to a is a vertical asymptote. So hopefully, not hopefully, but if you did come from Math 126 and or 7, we talked about asymptotes a lot, horizontal or vertical. So the line x equals a is a vertical asymptote of y equals f of x. if at least one of the following is true. So the first one, if the limit as x approaches a of f of x is equal to infinity, well then the line x equals a is a vertical asymptote. So let's go back to this example here. When my a is 0, these values do what? They approach positive infinity. So because it's approaching positive infinity, the line x equals a, basically the y-axis, is a vertical asymptote. And it counts if we come from the left or the right. X approaches a from the left of f of x is infinity, or limit as x approaches a from the right of the function is positive infinity. So if I was just looking at a one-sided limit, I was just looking at the left side here. As x approaches a from the left, it's still going to infinity, so x equals 0 is a vertical asymptote. And same idea is just to the negative. So the limit x approaches a of f of x is negative infinity, or limit. So the first one is just x approaches a. I think I said from the left, but no, just x approaches a. If it goes to negative infinity, that's a vertical asymptote. As x approaches a from the left, that goes to negative infinity, vertical asymptote. Or if the limit as x approaches a from the right of the function is negative infinity, again, is a vertical asymptote. So if at least one of these is true, that's a vertical asymptote. This example here, actually what? All three of these in the first row are true, whether I'm coming from the left, coming from the right, or at that point itself, it's going to infinity. As I get close, but not actually at that number. So let's look at an example. So two parts here. We want to find first the limit as x approaches 3 from the right side of 2x over x minus 3, and find the limit as x approaches 3 from the left side of the same function, 2 over x minus 3. So is 3 in the domain? No, it's not, right? Because that'll make the denominator 0 for both of these, so I can't just use the direct substitution. So let's look at what happens here. So first, for number 1. So as x approaches 3 from the right, so that means what? 10, 5, 4, 3.5, 3 1/4, 3.1, 3.001, 3.0000001. So that means what? This denominator, if it's anything bigger than 3, so let's say 3.1, so 3.1 minus 3 is what? It's going to be a positive number, but the closer it gets to 3 is what? Well, it's going to become really, really little. So the denominator becomes a very small positive number. The top is what? Roughly 2 times 3 about, but we're concerned with the denominator. As the denominator gets really, 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 really little, what happens to this whole thing? Well, this whole thing approaches infinity, right? So just think about it. If you have, don't even think of this example, but if I have 1 over 10, small number, and now start making the denominator smaller and smaller. 1 over 1, bigger number. 1 over 0.1, bigger number. 1 over 0.0001, really big number. And the smaller this number becomes, the bigger this entire fraction becomes, i.e. it goes to infinity. So for number 1, as x approaches 3 from the right, this entire function goes to infinity. What about number 2? So as x approaches 3 from the negative sign, from the left side, sorry, as x approaches 3 from the left, well, what happens? 0, 1, 2, 2.5, 2 3/4, etc., etc. But this number is always going to be what? It's going to end up a very small negative number. So as the denominator, so again, let's think of this one. If it's 1 over minus 10, that's a small number. 1 over negative 1, negative 1. 1 over negative 0.1, negative 10. 1 over negative 0.0001, really, really big number, but it's negative. So it means what? It means this guy, as we approach 3 from the left side, goes towards negative infinity. So for number 1, the limit went to positive infinity. For number 2, the limit went to negative infinity. So by definition 2, that means what? So this is kind of a continuation of this problem here, but based on number 1, based on number 2, because I satisfy at least one of those criteria, it says that the line x equals 3 is a vertical asymptote. So if you were given this problem, if it said 2x over x minus 3, is there a vertical asymptote? Well, there is. Where? When that denominator becomes 0. So you remember that from maybe 126 or 127. So that's the end of video 1. The idea that our limits are going to positive or negative infinity, and what does it mean in the grand scheme? It means that there is a vertical asymptote at that point. So come on back, we'll look at video 2 for section 1.6.